As we track the evolution of systems, particularly since the Industrial Revolution, one of the things that we observe is that the complexity seems to be increasing, and in fact, that the rate of change seems to be accelerating.
It wasn't that long ago when an automobile was sort of two seats and a wheel and some pedals and a shift lever. We're driving more functions into the system, and we're driving more performance in those functions into the system, and the response of the system is to add complexity.
If you look at a smartphone, for example, it fulfills multiple functions. It's a camera, it's a communication device, it's a sketch pad. The big challenge is that in many cases, this complexity exceeds our human bandwidth. My favorite example of that limit is perhaps the mechanical watch. In a mechanical watch, you typically have 150 or so components. A single person can understand it, build it, fine-tune it. Often if we go beyond this, we need teams of people, where each person on the team will only understand their portion in detail and will have a somewhat simplified, abstracted view of the system.
Complexity shows for us in two aspects, really. One is the technical complexity, mostly represented through systems design, so the interdependency of components. We have about 10 to the power of 45 different technical configurations we can build out of the parts we have. The other complexity we find is project complexity. At any given point of time, our company runs between 100 and 200 projects that are adding features to the product over the next 10 years, roughly. So the forecast we have to do of interdependencies is incredibly huge.
There are a number of tools that we have in our toolbox for managing complexity. The first one I would say is very good stakeholder analysis. There's not only the customer, there's the user, sometimes the operator. So one has to understand what all these stakeholders want out of the project. Then we try to craft an image or a concept for the system, what the system is going to do and sort of notionally how it will work and what it will be made up of. Then there's a decomposition where we take the complex system and we break it into pieces and we look at the form and the functional interaction amongst those pieces, understand at that level of architecture. The same again, break each of those pieces into pieces and so forth.
Systems thinking enables us to translate complex customer requirements into solutions. Solutions that deliver the performance we expect in a repeatable and a consistent way.